All right, welcome back. You already know who it is. It's Chemistry Cantor. So let's get back into some good chemistry. On the last one that we looked at, we were given the percent abundance of different isotopes, and they asked us to calculate the average atomic mass. In this one, they're going to give us the average atomic mass, and then we have to calculate the percent abundance. Um, we have the answer key here, but we'll work through it. So we have copper, his average atomic mass is here. And then they also gave us the two isotopes. They gave us copper 63, his mass, and then they also gave us copper 64, 65, his mass. And so now what we'll do is we'll kind of set up our equations and work backwards a little bit. All right. So first things first, we need to have a system of equations. So I know that if I multiply this by its percent abundance and then add it to this one multiplied by its percent abundance, that's going to give me average atomic mass. So I want to go ahead and start setting that up. So I know that for this one it's 62.94 times some percentage. We don't know what it is, just some percentage x. And then if we add that to 64.93 times some percentage y, we don't know what it is. That's okay. We should get 63.55. All right, so we have the average abundance here, or percent abundance here, and this will give us our mass contribution. Percent abundance of this one, its mass contribution. If we add those two together, it should give us our average atomic mass. So now we also know that these are just a percent of 100. So in decimal form, I know that if I take this one plus this one, that's going to give me 1. All right, so now we have a system equation. So the first thing I'm going to do is I'll just solve for a variable. I'll just subtract y from both sides, and then now we have x is equal to 1 minus y. Once I get that, now I can go in and I can substitute in this equation here. So if I were to substitute in, we'll have 62.94 times 1 minus y plus 64.93 times y equals 63.55. And then from there, we just work and solve for the variable y. So this will be 62.94 minus 62.94y. Then I'm just factoring in, of course. And we'll have plus 64.93y equals 63.55. And then looks like we can kind of combine like terms and move this over to the other side. So if we get our calculator. All right, so after we plug and chug in our calculator, we'll combine these two, 1.99y. Then I subtract this and subtract from this side, 0.61. And then we'll find that y is going to be equal to 0.31. All right, and now that we have y, I can go back in and I can find out what x is. But just this is, if I put this back in percent form, well, that's just 31%. So for y, this would have been 31%. And then, of course, this is just what's left over, so that would be 69%. So if I do 100% minus 31, that's 69. All right, so once we get here, once I find my y value, I'm just going to put it back in here. So 1 minus y gives me the other portion, and then from there, find out. So 64.93 is 31%. Rounded up, 62.94 is 69%. So that's how we can take the average atomic mass and find the percent composition